As you should already know, this whole chapter is about rational expressions. This section that we're doing, 8.4, is about multiplying and dividing rational expressions. So when you think about the word rational, a fraction should come to your mind because rational means fraction. So a rational expression is any expression that's inside of a fraction. In simplified form, that would mean that the numerator and denominator have no common factors. In other words, you can't cancel anything out of the numerator and the denominator. There's no common factors left. And you can only simplify when we're working in multiplication. So if we look at our first example, we're going to simplify rational expressions. This is a rational expression. There are expressions within a fraction. So that's a rational expression. To simplify this, you'll see that we can't cancel anything out because we're not working with multiplication. Like we have something minus something minus something on the bottom. We also have a term minus another term. So this is not multiplication. You can't just cancel out things. It doesn't work like that. So to get this into multiplication, what you're going to do is factor both the top and the bottom. So you're going to have to remember all those factoring skills that we talked about in previous chapters. Here we're looking for factors of 12 that subtract to give you 4. Remember that this subtraction means that they're going to be opposite signs. We have a plus and a minus. The two factors would be 6 and 2, 6 minus 2. And since this is negative, the bigger number needs to be negative. You're going to do the same on the bottom. X squared minus 4. 4 is a perfect square. This is the difference of two squares. So the two factors are x plus 2 and x minus 2. Now do you see that we have binomials multiplied times each other? Like now we're in multiplication. So now you can cancel things out that are in common. And on the top and the bottom we have an x plus 2. So what we're left with is x minus 6 over x minus 2. And this is your final answer. So if we look at another example, we're doing the same thing. You're going to try and factor the top and the bottom to see if you can cancel some things out. So here on the top, we're looking for factors of 6 that subtract to give us 5. And this subtraction means that we have different signs. We have a plus and a minus. And the two factors of 6 that subtract to give us 5 would be 6 and 1. And since the middle term is negative, the bigger number needs to go with the negative. On the bottom, 1 is a perfect square because the square root of 1 is just 1. So the factors of 1 squared minus 1 are 1, x plus 1 and x minus 1. Your common factors are x plus 1, so you're just left with x minus 6 over x minus 1. And that's your answer. Simple enough, you just have to remember all your factoring tricks. So now let's deal with rational expressions that are just monomials. Monomials being one term. This, just 5x squared times y, this whole thing is just a monomial because it's one term. Binomial would be 2, like x plus 1, 2 terms. Now there are a couple of different ways you can solve these. You can multiply first and then simplify, or simplify, then multiply. I honestly think it's simpler to simplify first, so then you're not dealing with huge numbers. But some people like it to do it the other way, so it's up to you. You decide what method you like the best. Now the reason we can just start canceling things out is because this is all multiplication. There is no plus or minus sign anywhere, so we can just start canceling out factors that are in common. So for example, anything on the top and bottom we can cancel out. So like this 5 and this 10, we can take out a 5 and the 10 we're left with a 2. Same with this 2 and the 6. The 2 cancels out and we're left with 3 because 2 goes into 6 3 times. Then you can start working with your variables. It looks like we have y here and a y squared here, so that's 2 more y's. So really we have 3 y's on the top. And there's a y cubed right here. So a y cubed and 3 y's on the top cancel out. On the bottom, we just have 1 x, and on the top it looks like we have 5 of them. So we can only cancel out 1. So we'll cancel out 1 x down here, and we'll cancel out 1 of them up on the top. So when we're all said and done, we're left with, we have this 3 right here, and we have x to the third times x, so we have x to the fourth, and all of our y's cancel out on the top. And on the bottom we have left a 2 and a y. And that's our final answer. If you cancel it out properly, your answer in the end should have nothing in common. You shouldn't be able to cancel out things. If you miss something, then you get to this step, you might have to cancel out one more time. It just depends. This next one, the same thing's going to happen. Again, you can multiply straight across first and then cancel out everything, but I don't like to take 9 times 12 and you'll get huge numbers. It's just easier to cancel out first. So like this 9 and 27, 9 goes into 27 3 times. This 3 and the 12, 3 goes into 12 4 times. And then we can deal with our variables. Start with x, I guess. There are 2 x's in the bottom because we have x squared. And it looks like there's 7 in the top. So we can only cancel out 2. So if I cancel out the 2 on the bottom, and on the top I'll cancel out 2. Then we look at our y's. We have y to the third and y squared, so there's 5 y's on the bottom. And it looks like there's a y to the fifth right here, so I can cancel out all the y's on the bottom and that y to the fifth on the top. So when you multiply, we're left with 4. And our x's, we have this x to the fourth and 1 x over here, so we have x to the fifth. And the y's, we were just left with that 1 y. On the bottom we have the 3, and all of our variables canceled out. So this is your final answer. Now let's look at some where we're not just multiplying monomials, we're multiplying a whole nother polynomial. The easiest way to do these is to factor and then cancel out. And you should see when you do this, things kind of cancel and it works out pretty nice. So the first thing I'm going to do is I'm going to factor each of these, each numerator and denominator. This part right here, we have a 4x minus 4x squared. I can pull out a 4 and an x. And when I do that, I'm left with, I pulled out a 4x, so I have 1 minus, if I pull out a 4x here, I'm just left with an x. I have a times in the middle. Let's go to the bottom here. Here I'm looking for factors of 3 that subtract to give me 2. This minus tells me that they're going to be opposite signs. And 2 factors of 3 that subtract to give me 2 are 3 and 1. And since the middle term is positive, the bigger number needs to be positive. Over here, I'm looking for factors of 6 that subtract to give me 1. Hope in your mind you're thinking 2 and 3. This minus means that they're going to be opposite signs, and since the middle term is positive, the bigger number needs to go with a positive. And on the bottom here, it's just 4x, that doesn't really factor. So this is what we come up with. So now you can cancel out all the things in common. So this 4x goes away, this x plus 3, this x plus 3. And you have left this 1 minus x and x minus 1. And they look similar, like you can cancel them out. But you can't quite just yet. I'm going to show you a little trick. If you multiply, what you have left on the top is 1 minus x and this x minus 2. And on the bottom, you just have this x minus 1. Well, if you pull out a negative out of here, it's going to switch your signs around. So I'm going to go down here, and I'm going to pull out a negative. If I pull a negative out of here, that makes the 1 negative and the x positive. Just changes my signs. So I have negative 1 plus x, which is x minus 1 if I just flip this around, which I'm going to do right now, so it looks nicer. And then I have my x minus 2 over x minus 1. So now my x minus 1's canceled, and I'm just left with negative x minus 2. And that's your answer. I'm going to go down to one where we have multiplying and dividing. Remember that dividing is the same thing as multiplying by the reciprocal. So your first step when you have simply dividing or multiplying and dividing is to rewrite this so it's all multiplication. So I'm going to have x over x plus 5 times 3x minus 5. And now I just said dividing is the same as multiplying by the reciprocal. So you change this multiplication and flip your fraction. And now you should be able to factor and cancel out just like you were before. So here we can already see that these x plus 5s are going to cancel out because one's on top, one's on the bottom. Let's factor this right here. So I'm going to move down. I have x times 3x minus 5 times 1 over, because the x plus 5 canceled out. And we can factor this because this is the difference of two squares. 9 is a perfect square and 25 is a perfect square. So if you factor this, you should have 3x plus 5 and 3x minus 5. You just use the square roots of each. So then, magically, your 3x minus 5s cancel out. And your answer is just x, because you have this x on top, over 3x plus 5. And that's your answer.